Hello, my name is Jake DeVos, and this is my presentation of selection, use, and evaluation of multiple representations in science. For this, I decided to use the standard from Science Georgia Standards of Excellence for Earth Systems, SES6, obtain, evaluate, and communicate information about how life on Earth responds to and shapes Earth's systems. Part D, analyze and interpret data that relates to changes in global climate, to natural and anthropogenic modifications of Earth's atmosphere and oceans. So I've chosen 5 representations that I'm going to discuss multiple questions about, and they're going to be around global warming and how it's going to affect the atmosphere and the oceans. So here we have our first representation, how global warming works, and there's a lot going on here. I understand that's not the best for students. There's probably too much going on for them at this point, for them to totally grasp what's going on. Maybe a little bit of cognitive, an excess of cognitive load going on here. However, I think it's a very important model of global warming, and I wanted to start off with this diagram first. And I'm okay with a little bit of cognitive load. I'd like to talk them through this and kind of point out a couple things about this representation. For one, the arrows. These denote the sunlight and how it's interacting with the atmosphere. Notice how we have more arrows going down than we do going up, which denotes that we have more sunlight being contained inside of our atmosphere. And our main reason why we're having that is that carbon dioxide that we see there. And that's going to be 2 forms of particulate representations. We have the symbol, not the symbol, the it is a symbol, but the CO2 that is going to be particulate because that is a molecule. And then we have the individual tiny little dots there. That's also going to be particulate. Those represent individual carbon dioxide molecules. This is how I think the students are going to interpret them, and that's how I think they should interpret them, even though we would never be able to see individual molecules at this level, so they need to know that about the scale of this, that they're not going to see that, and they know that already. And that again is a horizontal transfer of representations. Now, the carbon dioxide can actually interfere with sunlight's ability to get back out of the atmosphere. So sunlight gets into the atmosphere, and this carbon dioxide buildup will interfere with sunlight's ability to get back out of the atmosphere. So it'll bounce around in the atmosphere, and thus increasing the temperature. We also have on the very top right of this representation, we have a thermometer up there, and they're used to seeing a thermometer. They know what that means, but basically it's just saying that when the sunlight is bouncing around too much in the atmosphere because of the carbon dioxide buildup, that our temperature of the atmosphere is going to increase. And of course, this representation denotes that this carbon dioxide buildup is due to the burning of the fossil fuels denoted at the bottom of this representation. So how appropriate is this representation for the level of understanding of the students that I'm going to have? Well, I'm going to be dealing with 9th and 10th grade students, perhaps a senior class this next year, and I think it is appropriate. We have, as long as they understand that the arrows represent sunlight, and the more arrows you have pointing down means the more sunlight you have in the atmosphere. And as long as they understand that carbon dioxide is going to be keeping that sunlight in. What they might be confused with is the width of the arrows here. In this representation, they don't quite make sense. We have a larger width of an arrow pointing upwards, which they may think that it means that more is escaping. But I think if I point out that more arrows pointing down, count your arrows in this representation, that's what we're paying attention to. I think that would be an appropriate representation for my students. So after this, I would ask them, what do you think what is this going to cause in the atmosphere? What do you think the issues are going to be with more sunlight staying in? And I'd hope that they'd respond with temperature of the atmosphere rising, which is going to be another effect as well. But that's going to lead us into our next representation, being temperature. So here we have our second representation dealing with global warming, and in this case it's going to have CO2, carbon dioxide, and temperature and their relationship. So here the students can hopefully see that we have carbon dioxide being our blue line and the red line being temperature, and they both seem to have a relationship as they're both increasing together at the same time. I think the students are going to have a lot of problems with this, and I have something that I want to use here in a second to help with their understanding here. I'm going to add in another representation which should help them, and I'll explain that in a second. But for right now, I want to go over the levels and modes that we're looking at here, and if we're dealing with horizontal or vertical translation. So we see that this is obviously a graph. So a graph is going to be underneath symbolic representation, like math equations and stuff like that. So we have symbolic for sure. This is not a particulate, not a macroscopic, not a microscopic, not schematic. It's not anything else. None of the other representation matches here. I think symbolic is the only way you can call a graph. But that CO2 is a chemical formula, but to me that's a molecule. CO2 is a molecule, so that's going to be, I'm mixing in here through vertical translation a particulate, a submicroscopic, right? I have a molecule. So I'm also going to add in another, I'm going to add in macroscopic representation to this as well. So I think the students are going to have problems with being able to recognize what is really increasing here. There's a lot of numbers going on. So on the bottom, I'm going to show them that as I progress to the right, the numbers there are for years, obviously, but as I progress to the right here, my amount of carbon dioxide is increasing. So I'm going to show them as that line keeps on going to the right, that my carbon dioxide amount is increasing. So here I'm constraining information because I am pointing to the images on the bottom, which show them something familiar, where they're used to seeing that smoke as representing carbon dioxide, right? So if they see that representation, they're going to say, okay, that's carbon dioxide, and it's increasing because I just showed you that as I was progressing here, just like that the more and more I go to the right, the more and more smoke or carbon dioxide that there is. So my carbon dioxide is increasing, and then my temperature is also increasing, which I would then just point to that red line as well. And that carbon dioxide, that smokestack on the bottom, is going to be a macroscopic representation. So after this, hopefully they'll get the correlation between temperature and carbon dioxide amount, and that parts per million, that ppm. The students are going to have trouble with that as well. Same thing as milliliter per liter, but I would have to explain that out to them as well. But I'm going to move on here to my next representation, which I would then probably ask or point out that when temperature increases, something happens to molecules, which hopefully they've heard of in physical science. But what happens in molecules is they're going to spread apart. So somebody else is going to be affected here, and that's going to be water. Water is going to be affected. And so here we have multiple representations going on as well. We have two particulate submicroscopic representations of a water molecule. We have the space filling model, and then we just have the chemical formula. which is more symbolic, but I think of that as particulate because that is going to be our molecule for water is H2O. But yeah, so the temperature change is going to affect water as well. So I wanted to scaffold this before I move on to 4 and 5. But I just want to show them the basic molecule of water, and then I wanted to move on. So they should be familiar with this. They've seen the periodic table of elements. They know H is hydrogen, O is oxygen. They may not be familiar with a space-filling model, but perhaps they would be. I might want to explain that out just a little bit. But moving on to the next one. Here's our representation number 4, and we got a couple things going on here, so they might take them a second for their eyes to adjust here. But we have cold water, warm water, and ice, and that color on this molecule, the red color, is the same color I just had in the previous picture for oxygen here. So that's going to carry over from the last representation to this representation, which has been shown to aid students in their understanding of multiple representations, is if you use the same colors to carry over between different representations. So students should be used to seeing molecules by now, especially since the last one I've scaffolded this. But I'm afraid that their eyes might start wandering a little bit on this image. They might start looking toward the green dotted lines in the ice circle. What do those mean? I try to sway them away from looking at that and guide them towards warm water and cold water and the differences. And notice that they're expanding. They're farther apart. So that's what I would want to get across to them in this image, which I think they would be able to understand. I think it's appropriate. So if water gets warmer and it's expanding, what does that mean? Well, here we have some familiar representations that they can use to understand this a little bit more. I have a smaller flame and a larger flame. They're familiar with that. They're used to seeing that. I also have a beaker of water. They're used to seeing that. And a thermometer. They're used to seeing that as well. Now, they need to know there's a progression of time going on here that I'm going from, or I guess maybe 2 separate beakers, either way. I have one beaker that's cooler, denoted by the smaller flame, and the water is farther down, and then to the right, a progression of time has happened, and I have the water is higher up on that beaker because I've increased that flame, and they're familiar with that. They know that the flame means heat, and they also have the thermometer there, which is showing them that it is hotter, and that the water is farther up. Now, they might get a little bit confused, thinking that this is 2 separate things here, which I actually just said, but they're not 2 separate things. This must be a time progression that would need to be pointed out. Because if they're 2 separate, then maybe the second beaker started off with more water, right? So then the temperature here wouldn't matter. So it has to be the same beaker in a progression of time, and that would need to be pointed out to the students. And so finally, to finish off this representation, I'm going to add in this other representation, which we see that the more heat that you have on the bottom here, that the higher the temperature get. Now I'm including the amount, the numerical value. The numerical value of the degrees Fahrenheit here, which is a symbolic representation, being degrees Fahrenheit. But then we also have a macroscopic representation of this experiment happening here, where the more heat I put in, the more heat I put in, the farther and farther this water is going to get apart. So that's going to be a vertical translation between these representations. So then I point out, what does that mean for the Earth? Well, possibly that the Earth's water is going to start, the ocean's water, like going back to our standards, the ocean is going to respond to this increase in temperature by spreading out, by increasing in volume. And so what does that mean for the Earth? Maybe more flooding could start happening if this keeps on progressing, right? So anyway, those are my 5 representations and multiple representations here. Thank you so much for your time, and here are my references, and thanks again.